Bun găsit la emisiunea Știință și Cunoaștere. Astăzi avem un subiect îngrijorător, răcirea globală. În urmă cu 10 ani am început să studiez principiile fundamentale ale modificărilor climatice și multitudinea de factori generatori, descoperind cu uimire că de fapt activitatea omului e complet nesemnificativă în raport cu manifestarea marilor sisteme climatice de pe glob. Activitatea omului are o pondere semnificativă doar pe zone restrânse, doar în acele zone intens populate și industrializate. Am scris acest lucru într-un compendiu de 658 de pagini care este disponibil gratuit de mai multă vreme pe internet, în care am explicat multitudinea de interacțiuni și factori ce determină manifestarea climei pe glob. În baza celor mai recente informații pe care le-am primit de la Centrul de Meteorologie Spațială, am înțeles că se produce o modificare a activității Soarelui, care poate avea mai multe consecințe asupra noastră și resurselor de hrană. Fiind vorba de o premieră la Știință și Cunoaștere, am căutat cu mult efort un specialist climatolog care să întrunească simultan mai multe aptitudini și criterii ale profesiei sale, având în vedere posibilele critici sau amenințări care îmi pot fi aduse în urma difuzării acestor informații. Am vrut să elimin din start câteva dintre ele. Desigur, problema este aceea că părerile exprimate de acest specialist contravin dogmelor obligatorii implementate la nivelul tuturor țărilor industrializate. Dar îmi pun întrebarea dacă nu cumva încă în România aș mai putea uza de dreptul la libera exprimare fără să fiu pus sub incidența altor legi. Atunci când am publicat în cartea mea părerea ale unor climatologi care spuneau că nu omul e factorul esențial al modificărilor climatice, am primit avertismente și lămuriri cum că, de fapt, acei oameni, chiar dacă sunt climatologi, nu au fost niciodată pe teren și nu au făcut analize de laborator. Dar am avut și părerea ale unor climatologi care toată viața lor au lucrat pe teren și au cules mostre, au făcut analize. Mi s-a răspuns din nou, da, e adevărat, dar ei nu cunosc știința academică, tocmai pe motiv că nu au predat în universități. Ei nu știu să interpreteze datele pe care le-au obținut de pe teren. Acestea au fost problemele ce îmi păreau de netrecut și de nerezolvat până ce într-o bună zi l-am cunoscut pe climatologul de origine britanică Tim Ball, dar care cea mai mare parte a vieții sale a trăit-o în Canada. El a studiat mostrele de gheață arctică timp de 9 ani, le-a analizat în laborator, dar era și pilot militar, așa că în zborurile sale putea vedea fenomene meteo pe o panoramă vizuală de sute de kilometri. Dar avea și calificare de previzionist meteo în cadrul forțelor aeriene canadiene. Ceea ce a urmat mai departe au fost 25 de ani petrecuți în universitate, studiind climatologia la modul teoretic. Din punctul profesiei mele și al criteriilor ce mi-au fost comentate, cred că invitatul meu le îndeplinește în totalitate. Desigur, am fost întrebat, dar cum mi-am permis eu să scriu despre lucruri fără a mă consulta cu unul din cei foarte puțini climatologi acreditați IPCC din România? Îmi cer scuze că nu am făcut aceasta, dar dacă nu ar fi fost vorba de ceea ce veți afla din declarațiile invitatului emisiunii, chiar n-ar fi fost nicio problemă. La Știință și Cunoaștere se analizează știința bazată pe dovezi, iar aceasta nu e democratică și nu se supune la vot. Am observat cu multă tristețe cum așa zisele dovezi ale părții adverse, de fapt nu pot fi considerate dovezi științifice, ci măsluiri de date și contrafaceri. Acestea fiind spuse, vă prezint în continuare prima parte a interviului realizat pe Skype în Winnipeg, Canada, cu climatologul Tim Ball. Aici era aproape miezul nopții, ca de obicei, iar în Canada era cam ora 10 dimineața. Dear Professor Tim Ball, welcome to our Science and Knowledge TV program in Romania for the first time.
Well, thank you for the opportunity.
Because we met for the first time, please tell us for our viewers what is your academic background and if you worked in lab research, field research, where and when.
Okay, I was born in England, did my early education in England. I came to Canada, and I've worked in Canada since 1958. I served for 9 years in the Canadian Air Force, flying anti-submarine patrols in the North Atlantic, and also flying search and rescue in Arctic Canada. That's where I developed my interest in weather, because of course flying the weather is very important, but especially I learned about the Arctic weather of Canada and the Arctic region. Then I lost my flying category because of a hearing problem. And so I left the military and I went back to university and I took an honors degree, followed by a master's degree, and then a PhD in climatology at the University of London, England, Queen Mary College at the University of London, England. My research involved the records of the Hudson Bay Company, which is a fur trading company. They brought in thermometers to Canada as early as 1768, but they also recorded weather every day in a formalized scientific method, just like the ship's logs do. And so what I did was I took those records and created very long-term weather records to try and get some understanding of how much the climate changes. And this is one of the problems that we have today, is that the records are so inadequate for the claims that are being made. And this is still a problem. In fact, we've got less data now from instrumental records than we had in 1960. So I finished my doctorate at Queen Mary College while I was teaching at the University of Winnipeg. I taught climate courses at the undergraduate and graduate level for 25 years. I was also on many commissions of inquiry for the government and involved. One of the things that I learned, and this is important for the world and for what's going on, is all of the focus is on temperature, but what's really important in the short term for plants and animals and people is what is the precipitation going to do? And so from that, I very quickly learned that droughts are the most serious impact on plants and animals and people. So I taught a course in water resources for 25 years. And of course, that's a global issue as well. So that's how I got my background. While I was in the military, I also learned about giving weather briefings. And so I became an operations officer, giving weather briefings for the people going out on searches. So my whole career really has involved weather and then later climate. And since I haven't really retired, I continue to research and publish. I was most recently involved in the non-intergovernmental panel on climate change report that provides what the official government reports are not providing. So I'm still very active in what's going on.
But did you had any field research regarding the climate?
Yes, my field research involved with the weather stations in the Arctic region, particularly at Churchill and York Factory. And then it involved comparing those records with other data or sources of climate information, such as tree rings, for example. But most of my work was involved in the lab in reconstructing long-term weather records, because until you've got good weather records and good data, you really can't reach any scientific conclusions at all about what's going on.
Now we are entering directly into the topic of climate changes, which is a very large one. Already thousands of books were written in the last 50 years, so obviously we cannot cover the topic in 1 or even 2 hours of TV programs, but at least we should try to analyze some issues. And in our first part program, I propose to discuss about the role of the sun in climate changes.
Sure. One of the things, Chris, that it's important to understand for the listeners is that climatology, or first of all, let's separate. Weather is what you experience when you stand outside. And it's the sum total of everything from cosmic radiation in space to heat coming off the bottom of the oceans from geothermal and everything in between. So you're experiencing a total effect when you stand outside in the weather. Climate is the average of the weather. So if you record the weather on a daily or hourly basis, and then you average that out over time, that gives you the climate. And what I have focused upon is, first of all, the climate of regions, so that you've got, say, the climate of Romania or the climate of Britain, and then how climate changes through time. And that's really the important issue here. Now, one of the difficulties is that climatology is the study of the total of what creates weather and climate. And it's a generalist discipline, but we're in a world today in which everybody's a specialist. And so what you've got is a person that spends their whole life just studying CO2 or just studying one little piece of an enormously large puzzle. And we don't have the ability to put it back together again. And so what you have to distinguish in the literature and all of the research stuff is, what's the general picture? What are people like me, the climatologists, saying? And then what are the climate scientists? Because you see, a climate scientist is somebody who, say, has studied physics and then has specialized in just one small part of the whole climate puzzle. And that's why there's so much confusion about what's going on. And of course, you see it. The analogy I like to use is that the patient is lying on the table, and one doctor, the specialist podiatrist, is looking at the feet, and then another specialist is looking at the kidneys, the nephrologist, and the neurosurgeon's looking at the brain. But the nurse, who's concerned about the patient, is saying, but doctors, the patient's dead. You see, and that's the difficulty that we have in today's world. And people are living in a generalized world. And so when they hear about just one piece of it, they have no context for that. And so that's why it's such a confusing issue and topic. And by the way, meteorology is one of those specializations. Meteorology is actually a study of the physics of the atmosphere, which is only one small part of the total picture. But because meteorology came out into the public arena before climatology, it's what everybody knows. So meteorologists do weather forecasts. And the weather forecasting began in the First World War once they started flying, and the pilots needed good weather forecasts and so on. That's why most weather stations are at airports today. And so all of these factors have to be understood to understand why there's so much controversy over climate change and climatology.
I had recently watched a very well-organized material on YouTube about a compendium of observations regarding the sunspots, and I'd like to explain step by step those graphs, which I hope are available for public presentation.
Okay, great. Yes. Go ahead.
Maybe we should talk first about some basic issues before that. What is a sunspot?
Well, the sunspot is a darker area on the surface of the sun. The larger ones are about the same diameter as the Earth, and they appear at the equator, and then they move out towards the polar region in both directions away from the equator. And they rarely go more than 40 degrees away from the equator. They appear to be evidence of circulation of energies within the sun. They are cooler in temperature than the surface of the sun. The sun is about 6,000 degrees Celsius. The sunspots are about 4,600 degrees Celsius. But that's a contradiction, because they're more important in terms of how they affect the Earth in terms of the magnetism. We've known for a long time that when there are a lot of sunspots, the Earth is warmer. When there are fewer sunspots, the Earth is colder. But we didn't know what the mechanism was. In other words, you had a correlation. This was happening, and therefore that's happening. But in science, you have to be very careful, because it doesn't mean that there's a cause and effect relationship. And so it wasn't until 1991 that we started to get an understanding of what the relationship was. But Chris, if I might just for a minute to put this in a larger context, the sun is being virtually ignored in the official climate science that the United Nations are doing, the Intergovernmental Panel on Climate Change. The reason for that is that when they were charged with looking at climate change, the IPCC, the definition that they were given was only look at human causes of climate change. Well, if you do that, then it means you're not going to look at changes in the sun.
Yes.
But you can't understand what effect humans are having if you don't understand what are natural causes like the sun.
Yes.
So the IPCC doesn't look at sunspots.
We are arriving later on this program, but for the moment, please talk us about the historical observations of the sunspots.
Back to the sunspot question again. Galileo was the first to see the sunspots, of course, with his telescope on the sun. And one of the heresies that Galileo was accused of was that the church and the scientific belief at that time was that everything beyond the moon was perfect. Okay? And so when you found blemishes on the sun, that raised huge religious problems, right? And it's just like with Copernicus, it wasn't so much that he said that the Earth's going around the sun that the church were upset about. What they were upset about was he said the universe is infinite. And they said, well, if it's infinite, where's heaven? So he then became political by saying, well, it's an immeasurable distance. Well, the same thing with Galileo. When Galileo pointed out that there were blemishes on the sun, the view of that time of Western religions was that that can't happen. But Galileo was the first to record the sunspots. We've got all of his notes. That occurred in 1610. Since then, they've been regularly recording the number of sunspots. And so what they noticed, a fellow by the name of Wolf noticed that they come in patterns, that there are cycles to the sunspot numbers. So he started, yeah.
Yes, it's really amazing how clear they could actually see the sunspots with rudimentary telescopes more than 400 years ago.
Oh, exactly. And by the way, if the listeners are interested, there is a superb series called The Ascent of Man with Jacob Bronowski, who was a historian of science. And he pointed out that our knowledge and understanding of our world and our universe is determined by our technology. So once the telescope was invented, it changed our whole view of the world and the universe, and therefore ourselves. The microscope was another example. The Hubble telescope going out beyond the atmosphere. So all of these things have changed our view. But yes, you're right, for 400 years. But what Wolf did was he noticed that there were, if you counted the number of sunspots, there were definite cycles, and that the number of sunspots was minimal, and then over an 11-year cycle it increased, and then it decreased in an 11-year cycle.
Yes, we are arriving there also, but regarding this very old data about sunspots, how much of them can we integrate today in our modern interpretations?
Well, it's easy to integrate the data into the models. The problem is that it's not being done in the official government science because, as I said earlier, they said, well, we can't integrate that in because we don't know a mechanism. So if you go and read the Intergovernmental Panel on Climate Change report, they don't even mention sunspots. Now, the breakthrough came in 1991 with out of a guy by the name of Svensmark. Now, he wasn't in it right at the start, but he picked up on it since. What he realized was that the sunspots simply were visual evidence of a change in the whole mechanism of what the sun was doing, but particularly a change in the strength of the sun's magnetic field. Now, that magnetic field controlled the amount of cosmic radiation coming from space and reaching the Earth. As that cosmic radiation passes down through the atmosphere, in the lower atmosphere, it creates what are called condensation nuclei. These are small particles. Most of them are salt particles from the ocean or clay particles from the earth. They are necessary for water vapor, that is, water as a gas, to turn into a liquid. We had known for a long time that there weren't enough condensation nuclei in the atmosphere to explain all the cloud cover we had. Now, what Svensmark did was he explained that these cosmic radiations were the missing nuclei, but the correlation between low cloud cover and the amount of cosmic radiation reaching the Earth is almost 100%. And of course, that cloud cover then acts like putting a screen or a shield in the greenhouse. It's the major short-term control of temperature of the Earth. And so that's been in the literature since 1991 and was confirmed in 2008. And yet, as I said, it's not even included in any of the government computer models or even in their literature.
Yes. And now we are coming to what you were trying to tell us earlier, the next introductory question, which is what is a solar cycle? How many types of solar cycles are? What is their duration in years? And how do they affect our climate?
Okay. There's a much longer cycle of solar activity that we'll talk about after called the Milankovitch effect. He was a Serbian mathematician. But your answer about the sun's specific activity and solar sunspot cycles, they only consider from about 1741 the cycles and the number of sunspot counts to be accurate enough to be usable. We do have them, as I said, back to 1610. But Wolf determined that taking the sunspot number counts, he found that there was an 11-year cycle, I've already mentioned, but that's the average length of the cycle. It actually varies from 9 to 13 years. So the average is 11, but its variability is 9 to 13. Then every second 11-year cycle, the polarity of the sunspots reverses, which creates a 22-year sunspot cycle. Now, one of the things that we probably talk about a little bit later on is that 22-year sunspot cycle correlates with drought conditions in the middle latitudes. And that's something that Theodore Landscheid and I were talking about, and we're going to talk about him a bit later. So there's an 11-year cycle, a 22-year cycle, and then there's a 96-year cycle. And that's interesting because it generally tends to occur at the end of centuries. And when you look at the long-term climate record, you get quite significant climate change at the end of centuries. And then there are longer cycles than that. There's one at 150 years, and there's even cycles out to 2,500 years. How can we determine those long-term cycles of sunspot data? Well, the sunspot data correlates with energy coming from the sun, and it correlates with variations in carbon-12, which is one of the outputs of the energy of the sun. Carbon-12 is absorbed by living organisms on the surface of the earth, including humans. In a plant, for example, it's absorbed, and it converts, after the plant dies, it converts into carbon-14. That's been used for radiocarbon dating. The carbon-14, carbon-12 ratio has been used for radiocarbon. Well, but and that was one of the first uses of tree rings by a fellow by the name of Douglas back in 1930. And he noticed that the sunspot cycles correlated with the tree ring data that he was getting. So we can extend the sunspot cycle back by using the carbon-12, carbon-14 ratio. So you've got the observation from instruments from humans, then you add that onto the evidence from other natural sources, such as the tree ring data, and you can create a very long record. That's how we're able to see these longer cycles. When you want to find out cycles within a record, you run a spectral analysis. That it's a statistical program that tells you how often there are cycles in the data. And so, for example, when I did a run on drought cycles in the Hudson Bay Company records that I had, the 22-year drought cycle showed up very, very strongly. And that was what Landscheid and I were talking about. So that's the sunspot cycles. They affect the global temperature, as I said, by varying the amount of cloud cover. And it's the low cloud cover that is important here, and it controls the temperature.
What could happen if one or more of these cycles are having manifestations at the same time?
Superimposed?
Yes.
Yeah. Okay. This is another part of the whole debate that has gone on. I'll talk about it with regard to solar cycles. But in 1991, I believe it was Warsaw, there was a climate conference at which the East and the West at that time, which of course was the communist bloc as opposed to Western science, totally disagreed. The Soviet and the Chinese climatologists have long believed that there are cycles to the climate. And all you have to do is figure out what all the cycles are and then how they interact with each other. So if one cycle is causing an increase in temperature and another cycle is causing a decrease, what's the net result, okay? The Western world at that time didn't believe in cycles at all. They believed in chaos theory. They said that the weather systems and therefore the climate systems were chaotic and that there were no cycles. It's interesting because the Russian view about climate cycles came from the economic sector because a Russian by the name of Kondratiev noticed that there was a cycle of droughts that affected grain production, which therefore affected stock markets. That K cycle is still followed by a lot of economists. And in fact, most of the research into cyclical patterns of weather particularly is being done in the stock market. There are people that follow the cycle strictly. The difficulty now, the media and the political people interpreted the disagreement between the communist bloc and the Western world as a political disagreement, but it wasn't. It was a fundamental scientific disagreement. I happen to, having worked with Russian climatologists like Borisenkov and with Chinese climatologists, I happen to believe, and looking at my own records, I very firmly believe that there are all sorts of cycles going on of different lengths and different intensities, and that they all are interrelating with each other. And if you could sort out what the major ones are, you then have a better chance of predicting what's going to happen. But again, it comes back to how good your records are and how long your records are. So for example, if you've only got 100 years of instrumental temperature data, then any record that is, say, even a 50-year record, you're only going to have one cycle in it. So you really can't draw any conclusions. So this is part of the philosophical debate and the scientific conflict, and sorting out one cycle from another is extremely difficult with the present knowledge.
We are now approaching the recent times, and please tell us what happened with the sunspots in the last 3 sun cycles numbered 22, 23, and 24. We are now in the 24.
And we're now in 24. Yes, the sunspot cycles had been increasing in numbers. That is, the number of sunspots had increased up till the end of the 20th century, so close to the year 2000. Now, that correlates with a longer record by Uroskin showing that the sun had been increasing in activity for the last 1,000 years. And but since 2000, the sunspots numbers have decreased significantly. And cycle 22 and 23 were quite high sunspot numbers. Then 24 dropped down to a half of what 23 was. And now 25 is showing itself to be very low sunspot numbers. That is correlating with the global cooling that has been going on. Because despite all of their efforts, the temperatures are showing the Earth has been cooling down since 2000. And in fact, it's leveled off and there's a slight decline occurring. That's why a lot of the scientists like myself and some of the Russian scientists and Chinese scientists are saying that we're into a cooler period. Now, the number of sunspots in cycle 24 was comparable to the number of sunspots around 1800 to 1820. At that time, we had a minimum of sunspot numbers called the Dalton minimum, and that was a much cooler time period.
I have a question that puzzled me for a long time. If the sun activity slowed down between those minimums, why the climate had not been severely affected? Because from what I understood, the past cooling periods, the Dalton and Maunder, were present only when the sun had been on the minimum several cycles in a row, not just one cycle.
Well, that's right. I mean, the Maunder minimum, where you had a period of about 70 years where there was virtually no sunspots. And of course, that correlates climatically with a period called the Little Ice Age. So from about 1610 to 1680, with actually the coldest period around 1680, sunspot numbers were extremely low. The irony of that, of course, by the way, is that happened to cover the lifespan of the astronomer. Names just flipped out of my head right now, but he said he knew about sunspots because he'd read Galileo's literature, but he'd never been able to witness them or see them. Now, the other thing, by the way, is that in Central and Northern Europe and Central and Northern Canada, another thing that correlates with sunspot numbers is the appearance of the aurora borealis, the northern lights, because that's also related to changes in the energy output from the sun. So during the Little Ice Age or the Maunder minimum, there were virtually no aurora seen. And so this scientist whose life covered that span wrote an article in which he thanked God for living long enough to be able to travel up to Scotland and witness the aurora. But yeah, the minimums correlate with much colder temperatures. And the Little Ice Age, as I said, correlates with the Maunder minimum. The Dalton minimum, where you had very, very cold weather conditions around the world. Now, the Dalton minimum was a little bit difficult because almost in the middle of that, actually slightly towards the end of it, in 1815, I should say, there was a massive volcanic eruption in Indonesia called Tambora. And it put up so much dust that it cooled the Earth down by 1 degree Celsius. But the Earth was already cold at that time. So it just there's another example of cycles on cycles. But the correlation of cold weather with low sunspot numbers is very well documented.
Please tell us if we had severe climate on the period of solar cycle 14, year 1907, which is similar to what we have now, and if there is any probability that we might have colder winters in the next few years.
Yes, one of the things that people, the focus that I mentioned has been on temperature, and it's been on annual temperature. But if you just take seasonal, you can see that the summer temperatures haven't changed very much over time. All of the change has been in winter temperatures. So what's been happening is the winter temperatures have got higher. It's milder in the winter. And now the winters are getting colder again. And you're seeing that. And that's one of the first things that made the public start to raise questions. Say, well, we got this brutally cold winter. You can see it now across North America, record cold temperatures. The reason for this, Chris, is that as the Earth cools down, the way that the whole global weather system works is you think about the Earth and then you think about the atmosphere around it. There's basically two air masses. There is a dome of cold air over the polar regions, one over the South Pole and one over the North Pole. In between is warmer tropical air. Where those two air masses meet is called the polar front. Okay? And in the atmosphere above that polar front, that's where the jet stream blows. The jet stream wanders back and forth, and the polar front, there are waves in the polar front that wander back and forth. Now, as that dome expands, that creates the colder winters, but it also it creates increased variability of weather. So the jet stream waves, instead of being fairly low like that, they start to go well north-south like that. The farmers are aware of it because they see changes in the wind directions, but what you also see is increased variability of temperature. That's why now you're seeing record high temperatures, but also record low temperatures. But over time, the jet stream will level out, and it will be overall cooler in that dome. And so we've seen this before, and that's the pattern. Some people are predicting, as I said, the sunspot number cycle to continue to decrease until at least 2040. Some people are giving longer predictions. They think this cooling trend is going to go for 500 to 600 years. Certainly, when you look at the 300-year cycle of global temperature, that's certainly possible. But there is no doubt that the world is cooling down and will continue to cool down based on the basic evidence that we have.
This is very scaring, because on this winter we had only 3 days when temperature fall down below the normal range of the month, and in some regions had been recorded minus 34 degrees Celsius, and that was called a record of the coldest days in the last 50 years. Fortunately for us, the unusual cold lasted only 3 days.
Okay, what I was talking about was that one of the IPCC members who's studying Antarctic ice has come out and said that he still believes that CO2 and warming is going to occur, but what he's saying is that the cooler times are much worse for the planet and for people and plants than warmer times. And this is one of the things I've been talking about. All of the focus is on warming and how bad that's going to be. But as you've just said about Romania, a colder world, even a slightly colder world, is a much, much greater threat. And you see this, for example, they've said, with warming, there's a lot more people are going to die. But every year, more people die of the cold than of warm, even in these warm years. And so the government planning only for warming is so silly. What they should do is plan for cooling, because the adjustment to warming is a lot easier than the adjustment to cooling. And by planning for warming, you're making yourself unprepared for the cooling that's coming. You see that in the energy policies that are going on.
I remember a situation in England, and I read somewhere a long time ago, I don't have the original paper, I read about the fact that each winter 100 or maybe thousands of people are dying not just by extreme cold, but also because of the unprotected parts of the body, like fingers or head, favor blood clots entering the general blood circuit, causing heart failure.
Oh, sure, and especially the older people. But one of the things that you would experience in Romania and across Europe and Britain, that polar front that I talked about that separates the cold Arctic air or polar air from the warmer tropical air is a very, very distinct boundary. You can see it on the weather map. And just to give you an example, in 1943, they were recording the temperature with one of those big drums, with the pen that marks on the drum. So it was a huge drum, so they knew to the minute what the temperature was. at Spearfish, South Dakota, which is in the central United States or northern United States, the temperature went from plus 20 to minus 7 Celsius in 2 minutes. And that is not, that's a fairly, that's the long or most extreme recorded, but it is not unusual. I've driven in Canada across the prairies and gone through 20, 25 degrees Celsius temperature changes in a matter of 40 and 50 kilometers. And so the air on one side of that front is very cold. The air on the other side of it is very warm. And that's what was what happened in England that day. But again, the government, as I said, they're preparing for warming. They should prepare for cooling because you can adapt and adjust to cooling or to warming, I said, much easier than you can to cooling, particularly with crop types. Because ironically, you've only a 1 degree Celsius cooling of the global temperature virtually means Canada would not have an agriculture. Just 1 degree Celsius. And we know that, Chris, because after the eruption of the volcano Pinatubo in 1990, in 1992 or 91, the global temperature dropped 1 degree Celsius. We came very close to not having a harvest that year. It was only because the temperatures didn't drop until late in the fall that they were able to get the crop off. But it doesn't take much to cause a lot of the world food production to be seriously affected. And by the way, back in the 1970s, when global cooling was what the scientists were saying, we're heading for global cooling, the CIA were producing reports on how the global cooling would affect food production, cause social unrest and civil unrest, and that they'd have to be prepared to, the governments would have to be prepared to deal with this.
From all the climate driving forces known in nature, which of them are really the most important, which have maximum effect upon our climate? The sun, the oceans, the vegetation?
Yeah, the sun is almost the total control. It's modified within the Earth's system, both in the oceans and in the atmosphere, by water. Those are the two major controlling factors. And so the water vapor, which is water as a gas in the atmosphere, it's 95% of the so-called greenhouse effect. CO2 is only 4% of the greenhouse effect. So it gives you an idea. But the sun, in 3 different ways, affects the global temperature and climate. One is, I mentioned, the Milankovitch effect. This is the changing orbit of the Earth around the sun. It goes from almost circular, as it is now, to a much greater ellipse, as it was 20,000 years ago, and it keeps cycling through that. We've known that for 150 years. And so, of course, it affects the amount of heat energy that arrives at the Earth because of the distance. And the second thing is the tilt of the Earth is constantly changing. So it goes from a minimum of 21.8 to a maximum of 24.4. That changes how the sun's energy is distributed on the surface of the Earth. So the Arctic Circle and the equator and the tropics and so on, all of those are lines determined by the angle of the sun touching the Earth. The third one is what's called the precession of the equinox. That is, because of the tilt, because of the wobble, and because of the changing orbit, the date on which the day is equal 12 hours night and day is constantly changing. Where you see that is that our calendars are fixed, but the sun-Earth relationship is constantly changing. So every once in a while, we have to change our calendars to match up with what the sun-Earth relationships are doing. So those are major changes. And you can see in the ice core record, the 100,000-year cycle of glacial periods, ice ages, is on that orbital change, okay? So that's the major control. The second is the sunspot cycle, which we've already talked about. The third one is the energy coming out from the sun, the electromagnetic energy. That is the heat and light from the sun. And it it varies very small amount. So they say, well, it's the change is so small, it's not significant. But here's an interesting thing. In a computer model, if you change the amount of energy from the sun, we call it insolation, incoming solar radiation. If you vary that by 6% in a computer model, it explains all of the temperature variation in the history of the Earth. And so they say, well, it only varies by 0.1% or 0.16%. But that people are saying, well, that's of 100%. No, it isn't. It's of 6%. It's very significant. So you've got 3 sun changes. They only ignore the least important, or they only look at the least important one. They ignore the sunspots. They ignore the Milankovitch effect. They ignore the water vapor in the atmosphere, which is 95% of the greenhouse gases. People know, farmers know, how important the water vapor is in the atmosphere. So, for example, in the fall, if you've got clear skies, the heat escapes, you get frost. If you've got cloud cover, you've got a high water vapor in the atmosphere, humidity is high, the temperature stays high, you don't get frost. That's water vapor acting as a greenhouse gas. In the desert, in the central Sahara, they recorded at one place in southern Algeria where the temperature went from minus 3.6 degrees, from 52 degrees Celsius at noon to minus 3.6 degrees the next morning, just over 12 hours later. That occurs because there is no water vapor in the desert atmosphere to modify the temperature range. So that's why and of course then the oceans, you look at the temperature range, the further you get from Western Europe and you move inland into Europe, the colder it gets. That's called the continental effect. And so if you're near the ocean, your temperature range is modified. Your low temperatures are not as low and your highs are not as high. But when you get to places like Irkutsk or Verkhoyansk in central Siberia, the temperature range is from plus 40 in the summer to minus 50 and minus 60 in the wintertime. That's because you're away from the heat source of the oceans and the low humidity. So I would then summarize by saying the 2 most important things are the sun and the water. And yet both of those are essentially ignored in the climate models of the United Nations.
My next question is also very puzzling, because if that part of electromagnetic radiations coming from the sun, which is directly influencing our climate, is decreasing, well, according to Space Weather Center, another kind of electromagnetic radiation also coming from the sun is increasing in such a manner that the astronauts working in space should cut off their length of activity from 1,000 days to 700 days in order to have a safe level of radiation in their bodies. And even more recently, they published new information saying that airplane passengers should also take into consideration the fact that 5 hours flight at 11 meters altitude could lead to a level of irradiation equivalent with medical tooth X-ray investigations. So if you'll ask any medical specialist, they will tell you that the safety limit is about 4 to maximum 5 tooth X-rays per year. But why these types of radiations are increasing?
Well, it's relatively simple. The answer is that there are a multitude of radiations, and they're operating over a multitude of wavelengths. So, for example, your eyes are designed so that they can only see what's called visible light, right? Now, there are other radiations on that spectrum of electromagnetic spectrum. You've got ultraviolet, that is beyond the violet, which is the color at one end of the rainbow. And then you've got infrared, which is beyond the red on the other end of the spectrum. Your eyes are designed to only see that one spectrum. But you could have changes in the light colors, the visible light that you can see, which are not going on in the other spectrum. Right now, this is what was going on with the so-called ozone hole and ozone thinning. they assumed that ultraviolet radiation was constant. And therefore, if you assume that, because ultraviolet creates the ozone, ultraviolet hits oxygen, splits it into single oxygen, they form into O3 to create ozone. So if you're measuring a variation in the ozone, and you say, well, the ultraviolet is not varying, then you look for some other explanation to variation in ozone. We know that the ultraviolet radiation varies now a great deal. So that was really the explanation. So what the people are telling you is they're saying, well, look, these measures and these wavelengths of electromagnetic or cosmic radiation are varying, but that isn't varying or is not the same ones that are getting through the atmosphere to create the cloud in the lower strata or in the lower atmosphere. So you can have different things going on all of the time from a single source. And this is the mistake that we make. See, for example, they assume that just because there's a sunspot cycle of 22 years, and Landscheid and I talked about this, that you should see that 22-year sunspot cycle in every measurement that you have, but it doesn't happen. So the 11-year sunspot cycle is evident in most of the temperature records, but it isn't evident in the precipitation record. The 22-year cycle isn't evident in the temperature cycle, but it is evident in the precipitation cycle, but only in the middle latitudes. So you can't assume that because a source of radiation is coming at you, that it's going to affect everything all at the same way and at the same time. So yeah, the radiation that can affect the astronauts and do harm to their bodies is different than the radiation wavelengths that are causing clouds to form or affecting radiation in other ways. Chris, just as an important point here, this is where we make advances in science. So, for example, with breast cancer, they had certain treatments of radiation and so on, and then somebody discovered, look, you're just using one treatment for all breast cancers. There are 10 different forms of breast cancer, and the treatment only works on some of them. So now, because of that, we've got a better understanding. This is the same thing that's going on in all areas of science, that you've got to recognize what is affecting what.
If we are coming back to the next graph from that video on YouTube, we have a compared view between solar cycles 3, 4, 5, 6 with 22, 23, 24. But still, this might not tell us a precise prediction. Could we be sure that this pattern is really going to be repeated?
Only in the larger term, because as I mentioned with the eruption of Pinatubo, the volcano. So we're back to the thing that if it was purely and solely the solar sunspot cycles that was dictating the weather, yes, then we could do that. But because there are other factors that can occur, all you can do is say that on a macro scale, long-term, variation in sunspot numbers does cause a cooling or a warming. But there are other mitigating factors or modifying factors that you have to understand and put into that.
And some of them are completely unpredictable, like the volcanic eruptions.
Yes. Exactly, volcanic eruptions. And by the way, the amount of dust in the atmosphere, that's a very, very complex thing, the volcanic eruptions. The volcano has a greatest effect if it's at the equator and it ejects the dust into the stratosphere. Once it's in the stratosphere, it forms water droplets and it affects the yellow sunlight. And so there are so many factors involved. But the total amount of dust and particles in the atmosphere is another important measure that we really don't have a good handle on.
The previous question is linked to the next one, and that is many science and governmental agencies are telling us that the difference between those solar cycles which in the past severely affected the climate is that now humans do have an impact over the environment. So the human activity could counteract against the trend of the solar cycle, and therefore we should not expect the cooling effect very soon. Is the human activity so strong?
Absolutely not. There's an arrogance to these claims about human impact. And then not only is there an arrogance, but there's a philosophical problem because, of course, they're assuming that whatever humans do and humans themselves are not natural, right? So they'll talk about CO2 that's produced naturally and unnaturally. Well, if humans are producing CO2, that's natural. It's like the German philosopher said, Goethe, he said, unnatural, that's natural too. So you've got that philosophical problem. But just to give you an idea of the amounts of energies involved here and what they're talking about, back when the ozone issue was going on, somebody said, why don't we produce ozone at the surface and pump it up into the ozone layer and fill in the hole? And then somebody pointed out that you would need more energy to replace the ozone that you claim is missing. You would need more energy to produce that than humans produce in total. And so we like to think, oh yeah, we can produce nuclear bombs, but one thunderstorm in the tropics has more energy than 25 nuclear bombs. So the energy scales that are involved, in terms of, for example, CO2, they claim that humans produce 9 gigatons of carbon dioxide every year. But their estimates of the amount of CO2 that the oceans produce is 90 to 100 gigatons. So in other words, their estimate is only accurate to within 10 gigatons, which is more than the total amount that humans produce. So we produce less than the error in their estimates of CO2.
Yes, but they still have answer for this, because they'll say, okay, there are 750 or maybe 1,000 gigatons of CO2 in the atmosphere, but from that quantity only 1% is moving. The rest is fixed, and they say human industry also produces 1% of that, and they said this is why human industry have the same influence.
That's absolute scientific nonsense. They played this game, Chris, from the very beginning. They used to say that if you put CO2 into the atmosphere, that you could distinguish it because the isotopes were different. There's no difference between a forest fire producing CO2 into the atmosphere or all of the fires that are going on around the world than humans burning a fossil fuel. There's no difference. They also said that, oh, well, we put the CO2 in the atmosphere, it'll be there for 100 years. They found out now that it's there only for 6 years maximum. So all of these stories about, oh, it's a fixed amount and it's this and that and the other, it's all done deliberately to promote the argument that human CO2 is causing global warming, and that there's simply no evidence. And worse than that, the increasing evidence is that CO2 isn't even a greenhouse gas.
Let me change the tape, and I thank you so much for this part 1 of our wonderful talks, and let's meet again on our next episodes of Science and Knowledge here on TVR Cluj, Romania.
Thank you, Chris.